Hi, everybody. I want to thank you for joining me today at UIKonf 2020, and I'm here to talk about Bluetooth. I am Leah Vogel. I am the mobile team lead and an iOS developer at OrCam Technologies. So, what are we going to talk about today? Today we're going to talk about the what, the why, and the how of Bluetooth. We're going to talk about what Bluetooth is, some comparisons between Bluetooth Low Energy and Bluetooth Classic. We're going to speak about the terminology and get familiar with it. We're going to speak about the why as all of you iOS developers care. And of course, how to use the Bluetooth technology using Apple's CoreBluetooth framework, some tips, some gotchas, and whether you know nothing at all about Bluetooth or even a fair bit, I hope you're going to come away learning something new today. So back in the day, I got my first real iOS development job at a little startup in Jerusalem called Glide. Glide is a video messaging platform, and at some point, Glide decided to embrace a new project called the Wristcam. And the Wristcam was an Apple Watch band with photo and video capabilities, which enabled the user to take photos and stream videos directly from their wrist. So the way the projects were layered, we had both a phone app and a watch app, and they were layered with the networking and communication and the data, and then the app UI and the logic. And each of the team members performed different roles inside of the team. So my roles were firmly in the top two. So I got to do a lot of work with WatchKit and SpriteKit, and I got to interface with external APIs like tweeting directly from the wrist and live streaming, and it was really a lot of fun. But regarding the communication and the networking, that was firmly in the SEP field. I heard the terminology, I heard the discussions about Bluetooth and the Wi-Fi and EA, external accessories, and MFI, but it really had nothing to do with me at all until it did. So what happened there? What did the change? In 2017, I joined OrCam Technologies. And in OrCam, we developed smart wearable devices, and they help the user interact with their environment in ways that weren't previously possible. So in this picture here, you can see our flagship device, the OrCam MyEye. And this is for people with visual impairment. And we have a number of other devices, including the newest one, which is for people with hearing impairment. So what happened was, now that I needed to interface with these devices using the mobile app and using Bluetooth technology, it became time for me to learn more about Bluetooth, how it worked, and how to use it. So let's start with, what is it? What is Bluetooth Low Energy? I'm sure you all know something about Bluetooth, that it's a way of communication and transferring data. So we're going to talk a little bit about the background. Back in 1996, there were a few companies like Intel, Nokia, and Ericsson. They were all developing their own short-range radio technologies. And Intel was working on a program called Business RF, and Ericsson was working on MC-Link, and Nokia was working on low-power RF. And they decided, instead of everybody developing their own platforms, that if they all got together and developed the platform together, it would be much more valuable both for the user and for them in the long term, instead of being competition. So together they formed something called the SIG, the Special Interest Group. The first 5 original people were Ericsson, Intel, Nokia, Toshiba, and IBM. So this Special Interest Group, how did they get the name Bluetooth? So a little bit of history. The name actually dates back over 1,000 years ago to King Harold Bluetooth Gormson. So he was, at the time, the king in Scandinavia, and he was very well known for 2 things. He was well known for uniting Denmark and Norway in the year 958, and for his rotten tooth, which that's how he got his nickname, Bluetooth. So how did a king from 1,000 years ago with a rotten tooth, how did that become the name of the technology that we use today? So 2 of the people in the original special interest group, Jim Kardak from Intel and Sven Madison from Ericsson, they were out for drinks one night, and they were discussing books that they had read recently. And Sven mentioned he read something about the Vikings, and Jim also read the Viking book, and he really identified with this king who went and united these 2 nations. And he says, hey, that's actually what we're trying to do. We're trying to unite the cellular and the PC world with this short-range wireless link. And so he codenamed this whole project Bluetooth. That wasn't supposed to remain the name. There were a lot of different names that were floated at the time. The one that actually won the vote for 4-1 was PAN. PAN was Personal Area Networking, and that was the IBM proposal, and that was supposed to be the name of the project. So about a month before the launch of this new technology, the legal department came up to the special interest group and said, hey, we got a problem. PAN is way too general, and we're not going to be able to use that as our name. So they had a fallback to Radio Wire. That was the Intel proposal, but there really wasn't enough time to check out all the trademarks and all the legalities of it, and so they wound up using the codename Bluetooth as the project. All right, so here's a little bit about the logo. These are runes. These are Norse runes, and we have a combination of the H and the B, and this is called a bind rune, which is kind of like a signature, and this is the logo of Bluetooth. Now let's talk a little bit about the timeline. You can see a really detailed timeline of the Bluetooth.com website that actually goes through all the years from 1998 until today, and all the different releases and the important points, but we're going to discuss a few notable milestones that are relevant to us. So in 1999, the first Bluetooth core specification, 1.0, was released, and this was BR, the basic rate. The basic rate of Bluetooth at the time was 1 megabit per second. And also notably in 99, the first Bluetooth headset was shipped. Then we move a little bit further in time. In 2004, a new technology in the Bluetooth was released called the enhanced data rate. And instead of being just 1 megabit per second, we now could have transfer rate of 2 to 3 megabits per second. So doubling and actually tripling the throughput. That makes a big impact on the data transfer. And also in 2004, 250 million Bluetooth devices were shipped. Then if we fast forward a bit to 2009, Bluetooth specification 4.0 was released, and also with it, the Bluetooth low energy technology. In 2011, Apple, who is, of course, a member of the special interest group as well, they shipped their first Bluetooth low energy telephone, which was actually the first low energy cell phone to be shipped at all. And also, they included the Bluetooth technology inside of the Mac Mini and a MacBook Air. In 2013, the Bluetooth specification 4.2 was released, and that really set the stage for the whole IoT revolution because there were a lot of specific capabilities in the release of 4.2 that were needed for IoT. And if we fast forward all the way till today, back in January in 2020, Bluetooth announced LE audio, low energy audio, which amongst other things has the ability of audio sharing capabilities and enhanced features for hearing aids. Apple already has its own audio sharing in the AirPods, but now Bluetooth has their own. So if we want to talk a little bit about the differences and similarities between Bluetooth Classic and Bluetooth Low Energy, Bluetooth Classic, as we said, is BR EDR, the basic rate and enhanced data rate, and then we have Bluetooth Low Energy. So some of the similarities are they use the same frequency. They both use a 2.4 gigahertz frequency. They both use the same frequency hopping mechanism to switch between channels to give the best user experience for people. They also have different security protocols that they both can use. As we can see here on the chart, there's different transfer rates. The low energy has in general a lower transfer rate, but it has a much quicker response rate. Like when waking up from sleeping, it takes Bluetooth Classic about 100 milliseconds to wake up and be able to transfer data, whereas Bluetooth Low Energy takes only about 6 milliseconds. So the actual wake up for the transfer is faster. Also, the different power consumption is the big highlight of Classic versus Low Energy, and you can even know that inside of its name. So what happens here is in Bluetooth Classic, whether or not you're transferring data, the communication channel between both parties remains established even if no data is being transferred. Whereas in Bluetooth Low Energy, it has kind of like a suspend mode. It goes to sleep for all intents and purposes and only wakes up when it has data that needs to be transferred. So this is a real important point when you have devices that really need to last for a long time on their battery. If you can imagine a device that is always plugged in, so the battery consumption is not really a factor. But when it comes to devices, especially wearables, if you can think of, let's say, a hearing aid or a continuous glucose monitor, these aren't devices that you want to have to charge in the middle of the night or the middle of the day. The user really needs them to be working the whole time. And therefore, when you have devices that the power consumption is so crucial, Bluetooth Low Energy is usually a very good choice. So how does this actually work? The Bluetooth specification that Bluetooth came up with, one of the things that they wanted to ensure is that there's going to be backwards compatibility, and there's a very strict protocol that people developing need to adhere to. So the very first layer of communication, there's something called the attribute protocol, and that is really how the characteristics and the communication methods are defined. They're all defined in a very specific pattern. And then on top of that, which is really what we deal with, which is the GAT, the general attribute profile, that establishes how the user data is going to be transferred. So the GAT is kind of like a meta layer on top of that, and that is what we're going to use. So then we have this whole world about a profile and services and characteristics, and this is how we build our communication protocol. So a profile basically defines a set of capabilities of services that are going to be available, and then the services themselves encapsulate a list of characteristics, which are the actual channels that we're going to use for our Bluetooth communication. And then we have an additional thing called a descriptor, which it's an optional thing, can give extra information about a characteristic. Well, this is all very abstract. Let's give an example. For instance, if we were talking about, let's say, a heart monitor. So let's say we have a service that's going to provide us with different information about this heart monitor. For instance, we might have a characteristic that's going to tell us the heart rate. Maybe we have a characteristic that's going to tell us about the body temperature. Maybe we have a characteristic that's going to tell us about the battery level. So all of these are different channels that you can listen to, read, write, depending on their access levels to get more information. And then a descriptor, for instance, would be, let's say we have the characteristics for body temperature. Let's say the descriptor would tell us if it's in Fahrenheit or Celsius. It's just a little bit of extra information over there. So again, the characteristics are really the channels that we're going to be communicating with. And I mentioned access control. So we can have characteristics that are read, write, and then there's something else we can do, which is called notify and indicate. So we can decide out of the characteristics if we want to receive notifications from them every time the data has changed. So then when we subscribe to these characteristics, we set that we want to be notified. Now, what does indicate mean? Indicate means that the member who is sending us the information wants to receive acknowledgement from the subscriber before sending more information. So that's called the indicate. So let's say the heart monitor is very important for it to know that the subscriber has received the information before receiving additional information. So it would send its data, wait for acknowledgement before it sends additional data. So there are pluses and minuses of having a system that uses indicate. Of course, the plus is then you have data integrity and you ensure that the other side has received the data that you think you're sending it. Whereas it also slows the process down considerably because you have to wait for that acknowledgement before sending each additional bit of data, and it also blocks additional data being sent. So depending on your use case, you decide if that is something that you're going to want or not. Another important thing to know when we're talking about Bluetooth technology is something called the RSSI, and this lets us know if the device that we're connecting to or listening to is in close enough range that makes sense for us to even want to listen to this device, if it's relevant or if our connection is going to be good. Because in general, users, they want their things to work. That sounds legitimate. So therefore, you want to choose if the device that you're connecting to has a good enough signal. So as you see here, the RSSI are usually measured in negative numbers, and the closer we are to zero, the better signal we have. So we're talking kind of about two players, someone who's going to be providing information and somebody who's going to be listening to the information. So these two players are called the peripheral and the central. Now, what's interesting is a peripheral and the central, they're defined roles in a way, but you can have the same peripheral and central also playing the opposite role. A peripheral can also be a central, so it's not written in stone. But typically, what we're talking about is the central is going to be the one who is initiating a connection to a peripheral device. The peripheral device is usually going to be the source of truth and giving us information, although you can also have the central providing information. Okay, so how does this work? How do we know who we want to connect to? I mean, if you were to turn on a Bluetooth scanner right now, it could be in your house. You have a whole bunch of Bluetooth devices around. So how do we know which one we want to connect to? How does this work? So the peripheral has a mode that it can advertise. It can say, hey, this is what I'm advertising. This is what I've got. These are the services that I'm interested in other people being able to subscribe to. Now, saying that, when you're advertising, the peripheral doesn't need to advertise all of its services or all of its capabilities, but it should probably be advertised the one that it's important for the central that's scanning to find it. For instance, when we go back to the heart monitor, if the heart monitor has a battery service and a heart monitor service, it could be that it doesn't even want to advertise its battery service because that's not really the highlight here, but we want to highlight what the central is going to be looking for. So there's all kinds of data that they can put inside their little advertising dictionary, and the central who's looking for it can pick it up, maybe the name of the device and its services and whatnot. And then we have the central who, when it wants to initiate its connection, it scans for devices that are advertising the information that it is looking for. So if we're looking to connect to a heart monitor, then we're going to be scanning for devices that are advertising the service that we are looking for. And then what happens? Okay, so let's say we have our peripheral who's advertising, we have our central who's scanning. Now you want to initiate a connection. The central requests a connection, and then we have a pairing mode. Now what happens in this pairing mode? So in pairing, the two sides, they exchange data about their capabilities, and they generate and they exchange some keys. And then there's an additional step of bonding, an optional step, where each side generates keys to verify the other's identity for future connections. So this is how the flow goes. Peripheral is advertising, central is scanning, central initiates a connection. During this connection, there is the pairing process, and once the pairing has been authenticated, then they two are free to communicate. So that's basically how the steps work. Now we discussed the what, let's go to the why. Why is Bluetooth Low Energy so popular, and why do we care? So one of the reasons that Bluetooth Low Energy is so popular is because it's low cost. Bluetooth is not an expensive technology. So price is always a factor when you want to develop things, especially if you're developing things on a large scale. If you can imagine, if you want to put Bluetooth sensors up in an entire hospital, for instance, you're going to look for some kind of technology that is cost effective. Another big point, as we said, is battery efficiency. And of course, the purpose. Bluetooth can be used for a variety of different purposes. Okay, why do iOS developers care about this? This is a big market. There are a lot of Bluetooth devices. As a matter of fact, the computer or the phone that you are watching this from is also a Bluetooth device. So not everybody, sorry. A lot of people have Bluetooth in their pockets all the time, and there are a lot of devices out there that can be connected to. Bluetooth.com on their website has published the statistic that in 2020, there are 4 billion devices scheduled to be released to the public. So that's a lot of devices. And if we just look a little bit on the IoT market, which is just continuing to grow exponentially. So a lot of devices are out there. A lot of them are using Bluetooth technology in a variety of different markets. There are so many different markets today that incorporate Bluetooth into their workflow, and they all have different capabilities. Some need authentication, some don't. Some need mesh working, some don't. Some need streaming capabilities or broadcasting capabilities. And one of the highlights about Bluetooth is because it's a relatively old technology. So it is well known, it's trusted, it's familiar, there's documentation, there's backwards compatibility. It's a framework that people are happy to use. Now, about iOS, one of the things that we are very, very lucky about is we've got great devices. Apple has really provided us with a good thing. I kind of feel bad for my Android contemporaries because they have to deal with so many different manufacturers, so many different models of devices with different capabilities, etc. But we've got our stuff going good for us. In addition, we have a very well documented Bluetooth framework, and we have a community of developers that are always here for you. They got your back. Basically any question you can think of regarding Bluetooth, anything that you run up against, it's been asked already, it's been answered already. You can find them on the Apple forums, you can find them in Stack Overflow. It's all good. It's all good. So how do we do it? How are we going to use our Bluetooth technology? We have our framework called CoreBluetooth. So CoreBluetooth has been around for iOS since iOS 5. So iOS 5, that's already back in 2011. So there are pluses and minuses in working with an old framework. One of the big pluses is the documentation. It's very well documented. Some of the minuses is it's an older API, so it's using a delegate pattern. It's not the most streamlined. There's nothing's shiny and block-based or reactive about it, but it works. It works. last year's WWDC in iOS 13, there was something new announced for the CoreBluetooth technology. Is CoreBluetooth now supports BR and EDR devices, the Bluetooth Classic devices, which until now was not possible. Until now, the CoreBluetooth framework only supported low energy, but now you also have the whole other slew of devices as well. All right, let's talk about how we set this up. One of the things you need to know about CoreBluetooth is you cannot run it on a simulator. So if you write your CoreBluetooth class and you try running it on your phone, the first thing it's going to do is crash. Why? There are some keyless things that you've got to configure. So if you're only supporting iOS 13, then you only need the first one over here, the Bluetooth Always usage description. That is what you need to be showing here. Interesting fact, I don't know if you noticed this when you upgraded your own phones to iOS 13, you might have noticed that a lot of the apps that you use all the time, all of a sudden were requesting Bluetooth Always usage description. Like, why do you need that? Facebook, why do you need Bluetooth always, etc. So Apple decided to crack down on their privacy, and any device that was using Bluetooth for any reason all of a sudden has to announce it. So Bluetooth always usage is one of the keys that you have to put in your plist, and it's the only key if you're using iOS 13. However, if you're supporting older operating systems, then you're going to have to put the second one in as well, which is the Bluetooth peripheral usage description. All right, another thing that you may or may not want to do is configure a background mode. And there are two background modes that you can choose. You can choose the Bluetooth Central and you can choose the Bluetooth Peripheral. Now, why would you need a background mode? Background modes are if you want your app to be woken up from the background when new Bluetooth data is received. You don't need to have this, but if you do, how do you choose which one you want? If you want to be the Bluetooth Central or the Peripheral. So you have to decide what role is your app playing. As we said, the iPhone could be both. You could be the one scanning for devices and initiating a connection, which means you're the central, or you can be the one who's providing the Bluetooth information. You could be the peripheral. So depending on what role you want to be, that's how you decide which background mode you want, and of course, which classes you're going to want to instantiate inside of your app. So if you're going to want to be the central manager, you're going to want to have your central manager delegate and your peripheral delegate to the device that you've connected to get the callbacks of the different APIs that you're going to be using. Whereas if you want to be the peripheral, then you have to instantiate the peripheral manager and you want to have your peripheral delegate. So for the purposes of this talk, we're going to discuss being the central. So here is the instantiation of the central manager, and these are the arguments that it has. This is what you want to consider. Of course, you want to assign it a delegate, because if you're not, I don't know why you're making your Bluetooth app. You're going to want some feedback here. Okay, with regards to the queue, if you assign nil, notice it's an optional. If you assign nil, then everything will be done. Excuse me, everything will be done on the main queue. Whereas if you instantiate your own queue, then this is the place to do it. With regards to options, again, this is an optional dictionary that you can pass. There are some keys that are optional here that you can configure. One of the keys, for instance, is you can tell the operating system that when this class is instantiated, if the Bluetooth of the device is disabled, the system will show an alert to the user to allow Bluetooth in their settings. Why is this convenient? Then you don't have to handle it in your UI or your flow at all. And another reason that you might want the system to do it is, I'm sure if you want to send the user to settings from your app, it just brings them to your app settings. And if you want them to configure their Bluetooth, you want them to go to the Bluetooth settings. So if you use this key, the system will send you to exactly the correct place, which is nice. Another identifier that you can pass here is a restoration identifier, and that is in case you want, when you're woken up from the background, to have your state restored. All right, let's talk a little bit about the delegate. The first delegate method on this slide is the only required one, because in order for you to perform any Bluetooth requests, you must be in a state called powered on. There are a few different states of the central, but if you're not powered on and you try doing any Bluetooth related things, you're going to get an API misuse error. So you want to listen to this first one, state powered on, then we want to do our stuff. Another example of a method here is the did discover peripheral. So this is something that you're going to want to listen to before you want to connect to a device. And honestly, you can do a lot of interesting things without ever even connecting to a device because, as we said before, the peripherals are sending out advertisement data. So you can get a lot of information without even having to connect it, depending on what kind of data your peripherals are advertising. So some of the parameters over here, you have the advertisement data and you have the RSSI. So you can decide if the device is close enough that you want to connect to it. An interesting thing. So if you have your central and you have your peripheral, presumably as you move your peripheral closer and further away from your central, the RSSI is going to change. So what Apple does, instead of them sending the delegate callback every time this changes, they aggregate it all into one chunk of data, and this method is not going to be called again unless the advertisement data of the peripheral changes. Like if it decides to advertise an additional service, then it would appear again. However, there is a key that you can pass when you're scanning for peripherals that says, no, I want to see duplicates as well. So every time it moves, you'll see it again and again. All right, so here is the breakdown of the connection process. If you want to be the central connecting to the peripheral, first of all, you need a central manager. You want to assign it a delegate. You want a strong reference to it. You wait for powered on. Then you scan for your devices, or you connect to a device that you already know. Save a reference of your connected peripheral. This is important. Otherwise, you're not going to get your delegate callbacks. And then you want to discover the services and characteristics. So you discover the characteristic of a service or a characteristic of a peripheral because, as we said before, they might not have been advertising all of their data. And in order to be able to read and write to the characteristics, you have to discover them. So in our heart monitor, that might have been advertising just the heart service. This is the time where we find out about the other services that it has, and then we decide which ones we'd like to subscribe to. Just because a service or a characteristic exists doesn't mean that we even care about it. So how does the communication process actually work? As I said before, this is a delegate API. Here's something actually that Android's got on us. Their API communicating with the Bluetooth devices, it's really request response and a lot cleaner than having to deal with this asynchronous communication. What is the drawback about this? Because you're sending a request and then you have to wait for a response totally asynchronously, and in the middle, some voodoo could happen, like your Bluetooth could go off. The user could disconnect their Bluetooth, and then you might get stuck in La La Land waiting for a response to your request. So you have to take that into account. When you're building your own state machine and you're handling your request and your response, you have to take into account that the state could change, and so you don't get left in the lurch. So we have two methods here for communication. We have the read and we have the write, and each one has a corresponding delegate callback. So read, we have did update, and write, we have did write. The did update is also called in response to a notify. So if the characteristic that you've subscribed to is notify, you'll get a did update without having to call read. This is important. What could possibly go wrong? A lot of things, anything almost. Actually, ironically, when I was setting up for this talk, I had a lot of issues connecting my AirPods with my computer via Bluetooth. So, haha on me. So, users expect things to work, and they don't always work like that. And the most common issue that we have with regards to Bluetooth is disconnects and reconnections. And handling that in the correct manner is really important. So, here is a very important tip here. iOS can hold on to a connection to your peripheral even though you thought that you already disconnected. So you can get into an interesting state when you're trying to reconnect, because if your peripheral is already connected to your operating system, then when you scan for it, it's not going to show up. It's not advertising anymore. It's already connected. Once it's connected, the peripheral typically turns off its advertisement in order to conserve battery. So this is the proper way in order to reconnect to your device. The first thing you're going to want to do is check if you've already have your in-memory peripheral, because if you've got your in-memory one, that's great. That's the one you're going to want to connect to. If not, we look for our stored UUID. We ask the operating system to give us peripherals with this UUID that it knows. So hopefully we can connect to the UUID that we've already stored. But if not, then we need to look for devices that are already connected with the services that we're looking for. And this is very important because we do have the option to scan for peripherals and not pass any services. And then we can find all of the peripherals in the area because it doesn't matter what services they're advertising. However, if we want to reconnect here, then we're going to have to specify which services we're actually looking for. And of course, last resort, if we don't have one in memory and we don't have a stored UID and it's not connected already, we're going to want to scan and look for it. Okay, this is actually something that I copied from a sticky of one of my coworkers who has this taped to her monitor. So after about a half a day of work of trying to work on a specific functionality, and no matter what she did, she couldn't get data to connect, things weren't happening, and she said, I'm just going crazy, what should I do? And I asked the classic question of, have you tried turning it off and turning it on again? This is not a trivial question when it comes to iOS and Bluetooth, because turning something off and on again can mean a lot of different things. You can restart your peripheral. You can reboot your phone. You can go into settings and toggle your Bluetooth on and off. You can actually go into your device that you're already connected to and forget that device. And when you say forget device, then you're deleting the stored keys that the device has saved in order to reconnect to the peripheral. So turning off and turning it on again can mean a lot of things. But I would say if you're having problems with connectivity, start with this one. Okay, this one had to take the cake. I was working one day and I see this error in the debugger and I'm like, what? It's a real error. It's documented. Some developer actually wrote that and documented. So I've seen unknown errors and I've seen unlikely errors. So have fun with that one. All right. Obviously, in the scope of this talk, we're not going to be able to talk about everything. So what I suggest that you look into later is, again, the options. There's different options that you can pass with regards to restoration and waking up the background and restoring to a specific state. Background limitations is very important because your app is not going to behave the same way whether it's in the foreground or the background. For instance, if it's scanning for devices, then once it goes to the background, the scan interval will be a lot less. Or if you're scanning and you haven't specified any services, it's not going to scan at all in the background. So that's something that you should definitely read about. And of course, best practices for power conservation, because we don't want to develop an app that's going to be your phone's battery hog. Let's talk about testing. Testing is a little complicated when it comes to Bluetooth because, as we mentioned before, CoreBluetooth does not mesh with the simulator. So we have to come up with different strategies. And another issue that you could run across is if you're developing your app to interface with a hardware device that's in development, you can get into a situation where you're way ahead and the hardware isn't ready yet and you don't want to get stuck. So you want to be able to continue developing your things without being held back. So how do we do that? Of course, we want to mock things. How can we mock things? So what I suggest is making some kind of Bluetooth protocol. And this protocol will have the essential methods that you need and that you're expecting, different states. So you'll be able to keep dealing with your flow, writing your testing, writing your unit testing, and be able to continue developing your UI without being dependent on the device that you are waiting for. All right, let's do a little bit of a recap. So we discussed what Bluetooth is. We discussed classic versus low energy. We discussed what a central is, a peripheral, profiles, services, characteristics, descriptors, RSSI, a lot of different words and terminology, which I hope are familiar to you now. We discussed why, the great potential in the cellular and the IoT markets, and of course, the how, the wonderful framework of CoreBluetooth, some of the gotchas, a few testing strategies, and I cannot stress this enough. Read the documentation. Read all of it. There is a lot there, but you'll save yourself so much headache if you just read the documentation. All right, now we can answer a couple more questions. So where do we go from here? A suggestion I would like to make is, as I said before, make a simple device scanner. You can scan for Bluetooth devices in the area. Start out, of course, not scanning for any services, and you'll see all of them. And then you can investigate. You can discover their services, their characteristics. You could try connecting with them. You can see the different RSSI changes and get a real feel for the process. And if you're interested in reading more, I wrote a short article in Medium, which basically details the whole Bluetooth and how it works. Bluetooth.com has a great wealth of resources. There's demos, there's documentation. I don't know if you really want to read a course specification. Those are thousands of pages long, but there's a lot of short things that you can read over there. The Apple documentation on Core Bluetooth is a must. Read it, enjoy it, and there's some really interesting Core Bluetooth tutorials out there, whether for the the watch or for the phone, and I think that you can enjoy some of those. So I would like to thank everybody here today. I really would like to thank the organizers who worked so hard to make this year's conference a success. They work hard every year, but this year was specifically challenging for everybody. And a special shout out to Sabine. And I would like to thank the audience who have been so respectfully quiet. And I really hoped everybody learned something today. I would like to wish you all good health and to enjoy the rest of the conference.